Hi my fetishes! Today I'm going to introduce you the new cores count video series. In this series we are going to investigate how games are scaling up with high amount of cores. But first I want to show you what the basis of these videos will be. The first subtopic will be what I want to present with this video series. Some of today's AAA games are using more than 4, 6 or even 8 cores, respectively threads. New CPUs like Ryzen, Threadripper and i9 CPUs will benefit from this development. And this development is also good for old high core count CPUs like old Xeons. Then I will show you which tools I'm using to get the necessary measurements. We are taking a closer look on RiverTuner Statistics Server, MSI Afterburner and the tool Process Lasso. The next one is what kind of results I want to show you and how they are structured. We want to know the behavior of a game beginning with 1 core, 1 thread, up to 12 cores, 24 threads with and without hyperthreading. In the last topic I will talk about the presentation of the results. There will be a lot of numbers and comparisons. They are presented as simple and compact as possible to not overburden you, but to get all the information we want to know. Some AAA games nowadays use more than 1 thread to create our beloved illusions. There are some, or should I say a lot, claims that games don't use more than 2 threads. To put it simple, this is not true. Game developers are doing a pretty good job regarding multithread optimization. Of course, not every game uses a lot of cores, but the most demanding AAA games will benefit of more cores. But wait a minute, there are a lot of reviews and tests in nearly endless areas of the internet which are claiming the opposite. No, games don't benefit of additional cores. Yeah, these reviews are correct. Then why further reviews? Because new CPUs have a fairly high IPC, which means every program and game will benefit of this higher IPC. In a very simple way, you can say 1 core that has twice the power can substitute 2 cores half the power. That's why modern games run very well on modern low core count CPUs and don't benefit that much of additional cores. So far so good. But what about our good old high core count Xeon CPUs? The cores of these CPUs don't have a high IPC, but they have a lot of them. I want to show you how games benefit of high core count CPUs when the IPC is not that high, compared to new CPUs. That's why this video series exists. Now we come to the part of how I'm testing this and what tools I'm using. Do I use several different systems? No, I don't. I'm using just one system and simulate all other configurations. I know, a simulation is not that accurate like a real system, but you should get the idea of it, how games will perform with additional cores. The used system, respectively configuration, will be mentioned in every video. I'm using MSI Afterburner with the RiverTuner Statistics Server, Process Lasso and Excel to put the data in shape. MSI Afterburner and RiverTuner Statistics Server record the frames per second, the frame times and the usage of each CPU thread. The monitoring interval is 100 milliseconds to get reasonably results. It is also possible to record this telemetry data with Hardware 64 in combination with the RiverTuner Statistics Server, but I had problems with stuttering every second causing bad frame times. I don't know yet what induced this behavior, but I assume it is one of the many sensors of the tool. A little digression. With this tool, it is possible to make such cool things like this telemetry data overlay in the upper left. Process Lasso is a very nice tool for our purpose. You can assign every single process to certain threads and simulate different systems. When I perform the one CPU test, the entire OS, including all background processes, are assigned to CPU 0 to 7. All others remain empty, which are used for the game. The 2 CPU test work similar. The difference to the 1 CPU test is the OS and background processes are assigned to thread 0 to 3 and 16 to 19. The remaining threads of the CPUs are used for the game. To test the hyperthreading skills of game engines, you need to understand there is no such thing like a dedicated hyperthreading core. Let me illustrate this in this screenshot. Behind CPU 0 and CPU 1 is 1 core. If the workload is on CPU 0, it can use the entire core for its own. The same happens if you just use CPU 1. But if you put the workload on both threads, one of the threads can use the majority of the core, the other thread will get what's left. I measure all core, respectively thread configurations with 1, 2, 4, 6, 8, 10 and 12 cores, with and without hyperthreading. And of course the Windows Caterer itself will be tested too. The Windows Caterer uses all 16 cores and 32 threads on both CPUs. This makes 29 different configurations in total. There will be a 1 CPU test and a 2 CPU test with the previous mentioned core configurations. There are some measurements that go beyond 8 cores and 16 threads on one CPU. This is not possible with my configuration. That's why 8 cores and 16 threads are on one CPU and the remaining cores and threads are on the other CPU. This will be the 1 CPU test. Up to 8 cores and 16 threads, the results of one CPU are meaningful. The 2 CPU test will clarify if a symmetric breakdown of the game workload will increase or decrease the gaming performance. For example, is there a difference between using 8 cores on one CPU or 4 and 4 cores on 2 CPUs? Of course, this comparison will work only with a maximum of 8 cores and 16 threads. The used hardware will be mentioned in each video. If not other quoted, I will use a GTX 1080 Ti to avoid GPU bottlenecking. All kinds of screen syncs are deactivated. There is no fast V or G-Sync active. All the raw data is prepared and put into graphs in Excel. The results are 6 charts and 2 tables. Each of them will be presented with a 10 seconds timer in the upper left corner, so you know exactly when the charts will change. There will be 3 charts about FPS and 3 charts about frame times. 2 with the 1 CPU test, 2 with the 2 CPU test and 2 with a comparison of them. The 2 tables show the workload distribution of the games. They will give us answers about how even the workload is distributed across the assigned CPU threads. The more consistent, the better the multi-thread optimization of the game is. So, what do you think? Is there anything you want to know about multi-thread scaling of games with more than one CPU? Let me know in the comments. Thank you for watching. If you want to buy games and want to support me, please use the G2A ref link in the video description. I would appreciate that. If you like this video, hit the like button and subscribe so you don't miss upcoming videos. I will see you in the next one. Have a good day.